In this video, we're going to be talking about correlation and causality. So a correlation really only exists between two variables when higher values of one variable consistently go with higher values of another, or when higher values of one variable consistently go with lower values of another variable. So some examples, there's correlation between the variables height and weight for people. So, it's possible that taller people tend to weigh more than shorter people. There's a correlation between variables like demand for apples and price of apples. So, demand tends to decrease as price increases. And there's a correlation between practice time and skill among piano players. That is, those who practice more tend to be more skilled. Whenever we're looking for correlations, it's usually helpful to look at what's called a scatter plot, which is a graph where each point represents values of two different variables. And whenever we look at those scatter plots, we can try to see whether there are relationships between the two data variables or the points on the scatter plot. So if there's no correlation, that means that there's no apparent relationship between the two variables. If there's a positive correlations, that means that both the variables tend to increase or decrease together. A negative correlation is when one variable increases while the other decreases. And then a strength of a correlation is how close the variables follow the general trend. So whenever we look at a scatter plot, we're trying to see how close the points are to actually following the trend versus how spread out the points are. So here's an example of a scatter plot that has a positive correlation. We can see down here on the horizontal axis, we have the weight in carats and of diamonds, and on the vertical axis, we have price in dollars. So it looks like as the weight goes up of the diamond, then the price also goes up, right? So this has a positive correlation because as one variable increases, the other variable increases. And on this one, we would say that this has a decently strong correlation because we can see these points are all trending in the same way, and they're all pretty close together for that correlation. Here's an example of a negative correlation on a scatter plot. So this time our horizontal axis is life expectancy, and on the vertical axis we have infant mortality, or deaths per 1,000 live births. And then we can see some different countries here. So if we looked at this point for Bangladesh, their life expectancy is somewhere between 50 and 60, probably around 56, 57, and their infant mortality is a little above 100, maybe like 105, 101, 103. But as we go further, we can see this has a downward trajectory because we have other countries here that as their life expectancy goes up, the infant mortality is going down. So since one variable is going up and the other one's going down, we have a negative correlation here. We can see it's decreasing. And I would say this does not have quite as strong of a correlation as the last graph because these points are a little bit more spread out than what we saw before. So this example is accuracy of weather forecasts. So we have scatter plots shown for two different situations whenever it comes to the forecast. So on the left we have same day forecast going from 20 degrees Fahrenheit to 60 degrees Fahrenheit, and then the actual temperature from 20 to 70. And then over here we have a 3-day forecast going from the same range of temperatures, right? So we're looking at what did they forecast versus what was the actual temperature, okay? And so we can see a positive correlation among both. On the left, we see a stronger correlation here because these points are more close together. And then on the right, this is not as strong of a correlation. It's all more spread out. And if you think about it, that kind of makes sense because for a 3-day forecast, it's not going to be quite as accurate as a same-day forecast. Some possible explanations for correlation is that we have to understand about correlation. It doesn't mean that one variable actually causes the other. That is the case sometimes, but more often than not, a correlation, could be just due to a coincidence. Another thing that could happen is that maybe they both look like they're causing each other, but it's really because they have a common underlying cause. And we're going to see examples of that in a minute. And then the third thing that could happen is that one of the variables really is the cause of the other. So we need to really ask ourselves whether, if there's causation or if it's just correlation. So here's an example where we have a negative correlation between infant mortality and life expectancy. The correlation here is probably more due to a common underlying cause. So if you think about this realistically, just because someone lives to the age of 75 doesn't mean that a child in their family is also going to survive past a year old, right? And so that would be, we can't say that the age of one family member is going to cause the age of another, right? So usually in this case, what's probably the common underlying cause is the quality of healthcare. So there is a cause there, but one variable is not causing the other. It's the healthcare that's causing both of them to go up or down. Another type of correlation we could have, so we have a positive correlation between ice cream sales and approval rating of the current president. Okay, so maybe as ice cream sales go up, also people are approve more of the president. Or as ice cream sales go down, people are less in favor of the president. But it's more likely that this is just a coincidence. I would say that probably ice cream sales and the president's approval rating are not actually related, but if you put them both on a graph, even if you saw an upward trend, it doesn't necessarily mean that one causes the other. Another explanation, like in this example, we have a negative correlation between age and the likelihood of being in a car wreck. In this case, this might actually be due to the fact that older drivers might be more experienced, where younger drivers are less experienced. So older drivers might be less likely to drive their car or to wreck their car. So as age goes up, likelihood of a collision might go down, causing a negative correlation. So this could be an actual cause, although we can't say for sure that one really causes the other.